Okay, so another point in the graph is easily found. We can plug numbers in for x, but we don't graph like that. We don't graph by making big tables. Maybe little tables so we can transform things, but not big tables. Okay? So we're not going to use a big table to figure out what this graph looks like. But we can get another point on the graph, right? The easy point is let x equal 0, because that's going to give us what? The y-intercept, right? We know that. So plug in 0 and you get negative 15. Nobody wanted to say it, but I think everybody knew it. And one person said, yeah, you plug in 0, but said it real quiet, so I couldn't understand it. But yeah, that was good. Even if you did say it a little quietly. Okay, so we have now the point 0, negative 15, right? Is that sufficient to draw the parabola? Well, you know what you could do? You can take the coordinates of these 3 points, plug it into ax squared plus bx plus c equals 0, get 3 simultaneous equations, solve them for a, b, and c, write your quadratic model, and you would get the same thing you get if you just multiply these out.
Like this way.
Okay? Understand what I just said? We got 3 points. You can always get the equation of the parabola if you have 3 points, right? Okay, well, you can do that. Now, what else can you tell me about this parabola? Like, could you tell me what its axis of symmetry is?
It's more on that side than this side.
Yeah, more on this side than this side because this is closer to the origin than this is, right? Okay? Can be more specific, anybody, about exactly where it would be.
-1.
And why do you think -1? I agree, but why?
Because you just gotta find where it's in the middle.
It's got to be halfway between these two, right? How do you get halfway between -5 and 3? Add them and divide by 2, or count. Well, no, you can count half. You know, it's 8 units from here to here, so you go 4 units from here to the axis of symmetry, right? Lots of ways you could do it, but the easy calculation is add them and divide by 2. Okay? So, you have the axis of symmetry. And I'm going to say it's equidistant from the zeros. Okay? So it's at x equals -5 plus 3 over 2 equals -1. So now we got x equals -1, -1. Okay? And what's the y-coordinate? How are you going to easily calculate the y-coordinate to the vertex? Well, when you find the vertex using the quadratic formula, the negative b over 2a thing, what do you do with it? And you're doing it. When I ask you to do it in the test, you do it, right? That's not the only place you got to know to do that. Okay? You're out of the context of a test. What do? You can pretend you're taking a test. As many of you still have to do this week, right? And you're going to have to do this. What do you do after you find the axis of symmetry? To find the coordinates of the vertex so you know how to transform the function, so you know what the horizontal and vertical shifts are going to be.
You plug it back into the quadratic.
You plug it back into the function, right? Okay? Plug it back in to the function. So we take x equals -1 and we plug it into the function. Where do you see the equation for the function? Do you see it anywhere on the board? Well, yeah, it's here. It's also here. Okay. So we plug -1 in here and here. And what do we get?
-4 and 4.
Negative,
-4 and +4.
yeah, -4 and 4. And when we multiply -4 and 4, anybody want to take a stab at that one?
-16.
Yeah, it's -16, right? Okay? Now, I'm just gonna say the vertex is then at f of -1, which is -16, hoping that you understand that to get to -16, we plugged the -1 into f of x, which gave us -1 minus 3, -1 plus 5, -4 times 4, which is -16. Okay? So now we have the point 1, -16. Now, if this is -15, where's -16? Not that far below, right? 6% further from the x-axis, approximately 6%. Okay? So not all that much further, but a little bit lower, and we have 0, -16. So vertex is at y equals f of -1, -16. Vertex is then -1, -16. And I've got 0, -16, which is pretty ignorant. Okay? -1, -16. Now we can draw our parabola, right? So here's our graph. Whoa! I was aiming for the wrong point. Okay, something like this. Got it?